Welcome back to a trigonometry revision video, this time having a look at right angle triangle problems. Find the value of A corrected 2 decimal places here. So we've got an angle 37 degrees 27 minutes and a side there. Step 1 is to sort of figure out whether it's a sine, cos or tan question, so labeling the sides would be handy. So from this angle we have an opposite and an adjacent, so I think that would involve tan. So we're going to set up a tan statement here that says tan of the angle, tan 37, equals opposite over adjacent, in this case A over 5.86. Now to get the A on its own, we're going to multiply both sides by 5.86, so it's almost like it moves over here and multiplies by the front of that tan bit there, 5.86 times the tan section. We'll type all that into our calculator and they ask us to round it off to 2 decimal places. So we decided it's a tan question, so the rest of the question is filling out the tan ratio sort of arrangements of opposite over adjacent and getting the letter on its own there. 4.49 rounded off to 2 decimal places we should be getting there. Alright, we're having a look at this one. We find a length of B here. From this angle we have an adjacent and a hypotenuse. So from your SOHCAHTOA, some old hags can't always hide their old age. You might recall that adjacent and hypotenuse is involved in cosine. So we're going to be using a cos ratio here. If we fill out cos from the angle, cos 52, adjacent over hypotenuse, so we've got B over 11 in this case. Now to get the B on its own, we'd be multiplying both sides by 11 and then throwing all that into our calculator. 6.77. We'd be expecting B to be less than 11 because 11 is the hypotenuse, should be the longest side, so we can have a check that that seems appropriate, and it kind of does. This one from here, we see that we have an opposite and a hypotenuse, so I'm pretty sure we might be using a sine ratio here. Sine from that angle is opposite over hypotenuse, so in this case C over 43.6. To get the letter on its own, we'd be multiplying both sides by 43.6 and throwing that into our calculator carefully. 40.22 meters. To type this into your calculator, you'd be doing 67, then the degrees, minutes and seconds button, and the 17 and then the degrees, minutes and seconds button. That's how you enter those double barrel degrees and minutes there. Alrighty, here we have an angle and we have an opposite and an adjacent. So SOHCAHTOA would suggest that's a tan type question. So this is slightly interesting though. We have tan equals opposite over adjacent, and we have to stick to that order. We can't go making it up ourselves. When we do that, we have a 5 over D. Now the special thing happens when, or special method is needed when we have the letter on the bottom. We can't just multiply by 5 because that happens in every other question. When the letter's on the bottom, it swaps places with the whole of the tan 57.42 there. So the D will turn up over on the left hand side and the tan will be underneath the 5. So when we type that into our calculator, we'll be doing 5 divided by tan 57 degrees, minutes and seconds button, then 42 degrees, minutes and seconds button, then pressing equals, and they want us to round it off to 2 decimal places. So careful with those ones. Stick to the order that the ratios tell you in sine, cos or tan, and if the letter ends up on the bottom when you do that order, then do that swapping type method. Swap the whole thing. Don't just swap parts of it. Find the value of this now. It's still a sine, cos or tan type question, but we're going to find an angle this time, theta. So from theta there, we might say, okay, what have we got? We've got opposite and hypotenuse, so let's do a sine statement. In this case, we can't do sine of an angle because we don't know that angle, so we'll just say sine theta. Opposite over hypotenuse is 10 over 12. Now the big thing is to remember here, when you're trying to find an angle, we have to press shift sign on our calculator, don't we? So it'll be shift sign 10 over 12 equals. And that'll get us 56 degrees 27 minutes. we might get a decimal from one of the displays. So if you press shift sign 10 over 12 equals, you might have to press the degrees, minutes and seconds button to get it into that degrees, minutes and seconds language, and we might have to round that off to get to the nearest minute. It might have been more than 30 seconds there that gets rounded off. So there's a previous one of our last videos, most recent videos, is rounding off angles, so you can check that one if you're not sure how to round that properly. Once again, we're finding an angle. It looks like a tan question. We have opposite and adjacent, so we'll piece together a tan statement there. Tan theta is 6 over 7. Once again, we'll have to press shift tan, 6 over 7 equals, and then our degrees, minutes and seconds button. See if you get 40 degrees 36 minutes. You might have had to round the minutes off, up by 1 maybe. Check out what the seconds would have been there. Quick sketch to illustrate the angle of elevation. Now the angle of elevation goes up from the horizontal, so it looks a bit like that. Draw a horizontal and draw an angle that's going up and put a little label on it. Angle of depression goes down from the horizontal, so that's what it looks like there. And to work with that, we've got to draw a diagram here. Angle of elevation to the top of a tree from a point 52 meters from the base of the tree. So maybe pause the video there, see if you can get a sketch happening there. Otherwise I'll do it for you. So there's a tree. I've got to try and find the height of the tree. We end up with a right angle triangle, and the angle of elevation is up from the horizontal, so that's where your 32 degrees 42 minutes is, and a length from the top of the tree from a point 52 meters from the base. That's why the horizontal distance is the 52 there. So then we're trying to find the height of the tree. We'll be saying, okay, from the angle here, what have we got? We've got an opposite and an adjacent. So I think we'll be using SOHCAHTOA, a tan statement here to start working on this. So tan from the angle equals h over 52 if you follow the adjacent over opposite over adjacent order, sorry. And to get h on its own would be multiplying by 52 both sides. And type that into your calculator, rounding off to the nearest meter they wanted. So careful diagram, and then pick whether it's a sine, cos or tan statement that we want to start off with. Angle of depression down from the top of a 4-meter flagpole. So that's pretty clear. If it's a flagpole, it'll be a pretty vertical one, I guess. And you've got an angle here, and then we've got to find out how far it is from the base of the flagpole to the rock now. So piece together a diagram there. You want to pause it and have a go? Or just watch me. So we've got an angle of depression, we've got a horizontal, and we've got an angle down from there. We've got a 4-meter flagpole. Now one key bit here is to notice that really we have, I'll do it in blue maybe, we have a situation where we've got a horizontal there and a horizontal on the ground, and this is like a transversal, so it sets up one of those alternate angles that we can use. See how there, see that there, that angle there is alternate to that angle there. So we've given us an angle of depression, but we can transfer that angle down to here because alternate angles are equal. And then we'll have an angle and a side on the one triangle, which was really what we need. So alternate angles are equal in parallel lines, and so you're able to transfer that angle of depression and kind of make it an angle of elevation. And that's good because then we've got two pieces of information on our triangle. And it's D. They want us, that's a rock, that ugly red thing. So we're trying to find the distance between that rock and the flagpole, which is just one of the sides of the triangle now. So we'll have a look and see whether we've got a sine, cos or tan. From this angle down here, we've got an opposite and an adjacent, so it's a tan statement we'll be looking to piece together. And it's one of those tan statements whereby the letters on the bottom, do you remember what we said in a recent example there? We swap places there with the D and the tan 2814. And we type that into our calculator and we get a distance of 7.4 meters, which sounds pretty good. So Drawing a diagram is important. You've got to know the difference between an angle of depression and an angle of elevation. It was interesting, that one, that we used the parallel line rule. Alternate angles are equal in parallel lines. That was an interesting one to come up in a trigonometry topic. Hope that helps, running through right angle triangle examples there and reminding you of a few methods. peterblakemaths.com. Catch you next time. Thanks for listening.